This question shows us an organic synthesis pathway. It tells us to name compound C, which is this molecule over here at the end of the synthesis, and it tells us to draw a structure for each of the compounds A and B. It gives us B, but we have to work out A. It tells us to state the reagents required for each step and to name the type of reaction involved in the conversion of B into C. So let's quickly draw out compound C. 4 carbons in this compound and 2 amino groups. So if we look at it, that's going to be 1 amino group on the first carbon and 1 on the fourth carbon, so that will be 1,4-diamino butane. So let's start on step 1. We have ethene, which is CH4 with a double bond between the carbons, and there's an electrophilic addition reaction occurring, which turns it into compound A. So the reagent for this will be bromine or chlorine, and when we do the electrophilic addition reaction with ethene, we'll get 1,2-dibromoethane, and that is our compound A. Let's go on to step 2. So we have the molecule 1,2-dibromoethane, and we get C4H4N2, so that's going to be the nitrile. So that actually will be our structure for compound B. I should write that in red, but I'm just going to box it up. And the way we get from this molecule to dinitrile, we'll actually have to use nucleophilic substitution with potassium cyanide. So if you remember, the cyanide ion is attracted by the electron deficient carbon, and the molecule undergoes nucleophilic substitution, and we'll get 2 cyanide groups replacing the 2 bromine atoms. We won't use hydrogen cyanide because we'll get toxic fumes of hydrogen bromide gas, which we want to avoid, and it will not dissociate into the cyanide ions as easily as the potassium cyanide, so we might not get a fully substituted molecule. So I'm going to write that here, not hydrogen cyanide. So in step 3, we go from this dinitrile to our 1,4-diamino butane. This is done through reducing the molecule with hydrogen gas and a nickel catalyst, or you could use lithium aluminium hydride or any other reducing agent that works to reduce nitriles, but this is the one that I'd go for, and this reaction is called a hydrogenation reaction. So the conversion of B to C is a hydrogenation reaction, or you could say it's a reduction reaction, but I prefer to say hydrogenation. Let me underline these two because they are our answers. I'm going to circle each marking point. So the first mark was 1,4-diamino butane. Then we have the structure of A, which is the second mark. Then we have the reagent bromine or chlorine. You could say chlorine and you get a dichloroalkane, but I use bromine in this instance. Another mark is for the drawing of compound B. Another mark is for the reagent potassium cyanide. Then the last 2 marks are for our reagent for the hydrogenation of the dinitrile into the diamine. 1, 2, 3, 4, 5, 6, 7 marks. Thank you for watching the video. I hope you found it useful.